Hello everyone. Today we'll start the new chapter, which is a really important chapter in math. We'll talk about sequences, functions, and graph. Firstly, we'll start with sequences. What is a sequence? Well, let's see some examples first. Sequences occur in many different places, for example, in nature, computer programming, science, engineering, and in design. You may know that a designer may want to decorate the kitchen or bathroom with tiles, so he would need to know how the sequences of tiles continues and how many of each different color tile he needs. So let's see some examples. Well, we have a lot of usage of sequences in nature and in our daily life. So let's see in nature first. What can you say for these figures? I'm sure that you have seen a lot of these examples even in your math projects about the application of math in our daily life or in nature. So you know that this structure is composed of a sequence, or the sunflower is composed of a sequence, or even these ones, the growth of these ones come up according to a sequence, and it means it is a rule for this shape. So the tiles, so you know that the designers need to put the tiles in such an order that they will form the proper form or the proper order of them. So the walls can be decorated with tiles like this or like this one. So there is a rule to decorate this one. Or even you can see this photo about the iPhone. As you know, there is again a sequence that is used, or a pattern used to make the logo of iPhone. Okay, to decorate it, it is the Fibonacci sequence, which we'll deal later. So sequences are used a lot. What is in common in all these photos that we saw? The common thing is that we have a set of things which are, or a set of numbers which are related to each other according to a particular order. So this one is the sequence. We have a set of numbers which are related to each other according to a particular order. So if we take a look in these photos, we have the first circle with radius 1, 2, then 1 plus 2 will become 3, so the radius of this one will be 3. 2 plus 3 will become 5, so the radius will be 5. 3 plus 5 is 8. 5 plus 8 is 13. So this one is used to make this logo. Or here we have some more detailed ones, so the rectangles, the circles, so it looks perfect because of this. You can see the intersection of the circles with the same radius and so on. So there are some rules to make these sequences, and they are used a lot, and they are very important in our daily life. Let's start to understand from the easiest one in math. Okay, so we'll learn how these patterns are formed, how are these rules found, or how can we find them. This is what we are going to do in this lesson. We have to configure out the rules. Let's see another example. It is given again a pattern. We have at the first one 1 point, the first let's say the first figure. At the second one there are 3 points. At the third pattern, it means at the third figure, we have 6 points. At the fourth one we have 10 points. So what is the relation between these figures? How can we find it? So it is 1, then it becomes 3. So I have added 2 points. It is 3, then it becomes 6. So I have added 3 points. It is 6 and it becomes 10. So I have added 4 points. So can we guess the next one? What will be the next one? So I added 2, I added 3, I added 4. So for the next one I have to add 5, so it will be 15. And for the next one I will add 6, and so on. So let's see how it can continue. Okay, so 1 point, 3, 6, 10, 15, and then you will add 6, 21. So this is the relation between these patterns. Okay, in each figure I have to add one more circle or one more point. Okay, let's have a look on the exercise that is found on your book. Let's look at this pattern or sequence. The pattern number is 1. It means the first term, let's say like this, the first term shows 2 points. The second term shows 3 points. The third term 4. The fourth term 5. So what is the relation between them? I have the first term, it has 2, it's like 1 plus 1. At the second one I have added one more, so it will be 2 plus 1, 3 plus 1, 4, 5, 4 plus 1, 5. So the fifth pattern or the fifth term will have plus 1, which will make it 6. What about the 20th pattern? What do you think? So since we added 1 to this one, okay, we have plus 1. So since I have plus 1, okay, for each term, and for this one it will be 6. For 20 again I will have plus 1 and it will be 21. So the 20th term will have 21 points. So how is this pattern number related to the number of dots? We have to add 1, as we said, we have to add 1 in the pattern number to get the number of points. Okay, so if I say that I have to find the 50th term, it will be what? 50 plus 1, which is 51 points. Okay, sorry. Plus 1, which is 51 points. What if you want to find the x terms? Okay, any term, or the nth term, any term. Let's denote with n. So the nth term will be what in this case? It will be n plus 1. Okay, so for the nth term you have to add 1. It will be n plus 1. In the same way we can think for exercise 2. So it is given 1, 3 points, 2, 6 points, 3, 9 points, 4, 12 points. So what is this relation? 1 times 3 will give 3, 2 times 3 will give 6, 3 times 3 will give 9. So the number of pattern or the number of term is multiplied with 3. So in this case I have what? I have the multiples of 3. So 5 times 3 will be 50. So here I will have 50 points. At B, again I have 1, 3, 2, 4, 3, 5, 4, 6. So what will be the fifth term? If we see the relation between the pattern number and the number of dots, we'll see that the difference from 1 and 3 in this case is 2. 2 to 4 again is 2. 3 to 5 is 2. 4 to 6 is 2. So 5 plus 2 will be 7. Okay, so here there will be 7 points because I have the difference 2 between the pattern number and the number of dots. So if I ask you the 10th term, it will be 10 plus 2, 12. Okay, let's have a look at C. It is a nice sequence. So the first term is 0. It means I have no points. The second term I have 1 point. The third term I have 2 points. The fourth term I have 3 points. So what about the fifth term? If we see the relation between them, we'll see that for the first one, 0. So 1 minus 1 will give me 0. 2, 1, again the difference is minus 1. 3, 2, minus 1. 4, 3, minus 1. So it will be 4. Okay, so 5 minus 1. 5 minus 1 will give me 4. So here will be 4 points. Okay, so we don't have only increasing or adding, we can have the difference, we can have multiples, we can have division, so we can have any rule to get the pattern. Here we have, for example, 1 3, 2 5, 3 7, 4 9. Again, what is the difference? For 1 I have added 2, for 2 I have added 3 points, for 3 I have added 4, so the rule change in each term. For 4 I have added 5, for 5 I will add 6, so this one will be 11 points. Okay, so the rule can change. So if this one increase with 1, the second one increase with 2. Okay, 3 plus 2 5, plus 2 7, plus 2 9, plus 2 11. Okay, so if I have increasing with 1 for each term here, the other one will be increased with 2. So this one is the rule for this one. Okay, let's have a look on the diagram at exercise 3. Now, it is given a figure which is composed of one yellow rectangle or one yellow part and two blue. At the second figure, I have 2 yellow, 4 blue, 3 yellow, 6 blue. So, can we draw the next two diagrams? So, what is happening? If this one increases with 1, the blue will be increased with 2. So, to draw the next diagram, let's draw it. Oh, this one is square. Let's take a rectangle. It means if I will add one more, okay, let's make it white. So I have to add one more, sorry, one more yellow, because the yellows increases with 1. It means I will have 4 yellow and how many blues? 8 blues. So if yellow increases with 1, the blue ones, okay, so if this one is yellow, the blue ones will increase with 2. Okay, so this one is the blue part. If you draw the next one, I will have 5 yellow and how many blue? 10 blue. Can we write this relation here? So 1, 2. Okay, for 1 I have 2. For 2 I have 4. For 3 I have 6 blue, for 3 yellow. For 4 yellow I will have 8 blue, and for 5 yellow we will have 10 blue rectangles. So how can we relate this number? In fact, we have added 2 in each of these terms. So if this one increases with 1, the blue ones increases with 2, but the relation between yellow and blue is 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. So this number is doubled. So we can say that in fact is 2 times number of yellow. Okay, so we are doubling. So how many tiles, blue tiles, are there if there are 10 yellow tiles? So 2 times 10 will be 20. 2 times 10 will be 20. Okay, so in this way we can find different rules about these ones.